Before starting the crawler, what I have done is that I have created a folder 3IAM glue input files in the data engineering bucket or 3IAM data engineering volume 2 bucket. And here I have created multiple folders. We have account folder, customer folder, ledger folder, loan and transaction folder. And inside of each folder, I have only one file. I have not loaded all the files from the finance dataset. I have loaded only one file. Of course, you can have multiple files here. Now in this case, it contains only finance account data 1, but if you want, you can upload finance account data 2, 3, or as many files as you want. Now, one important thing to note is that different files have their own folder. So account has a different folder, customer has a different folder, ledger has a different folder, etc. Now this is for S3 only. If you are using glue crawler to read databases or data warehousing systems, then this is not needed. This is a special consideration that you have to make when you use S3 as the data source. Now what am I going to do is that I'll use a glue crawler which will read these different folders and then store the schema in glue catalog. Now to do that, I'll have to go to data catalog, and here in the data catalog we have these databases and tables. Now if I go to databases, there are no databases as such, and of course there are no tables. The first thing that I have to do is that I'll have to create a database manually. That is something that has to be done manually, and I'll name it as 3IAM glue DB and then create the database, and that's it. Nothing else is needed. But I'll not create the tables because there can be hundreds or even thousands of tables across different data stores. I can have tables in S3 in the form of Parquet files. I'm showing you only CSV file, but there can be Parquet files also. I can have Lakehouse files also. Now in the Lakehouse, I can have tables there also. And of course, I can have tables in OLTP databases, NoSQL databases, and data warehousing systems. So as I said, there can be tens of thousands of tables and views, etc. I do not want to create them manually, but if you want, you can add a table manually also. There are two options: add tables using crawler and add table manually. But instead of this, I want to create a crawler, and the crawler would crawl the files which are there in the S3 folder. So these are the different folders, and we have CSV files here, and then create the metadata and store it here. I'm showing you using CSV files only. The steps would be similar for Parquet files in S3, or for that matter, different databases also. To create the tables schema or to store the table schema, I'll be creating a crawler. Now here I have clicked this crawler, and now I'll click on create crawler, and the name of the crawler is 3IAM finance crawler. Remember, it is nothing but just running a very small PySpark code which will load the data store using data frame reader, and from there, whenever we get the print schema, the output of the print schema would be stored in the data catalog, obviously in a much more fancy way. So this is the name of the crawler. Click on next, and there are various different data sources. It asks you whether our data is already mapped to glue tables. The answer is no, because we have not created the data at all. So I'll add a data source here, and there are various different options in the data source. You have S3, then we have JDBC. JDBC is Java Database Connectivity. These are mainly for relational databases. Then you have NoSQL databases like DynamoDB and DocumentDB or MongoDB. Then you have open table formats like Delta Lake. Then you have Iceberg and Hoodie. And then you have relational databases like SQL Server, MySQL, Oracle, Postgres, etc. Now in our case, I'll add the S3 source, and here you can have JSON, CSV, or Parquet files. You cannot have Avro files, you can have only Parquet files. The next one is network connection. I'll show you the connections shortly, not now. I'll show you the connections once the crawler is done. Now after that, I'll have to mention the S3 location. So I'll browse to the S3 folder, which is this one, 3IAM Spark and 3IAM input files, 3IAM glue input files. I'll choose it. And after that, there are three options. It asks you whether you want to crawl all subfolders or crawl new subfolders only, or crawl based on events. I'll mention crawl all subfolders because in that case, all the subfolders which are there inside of this particular folder, which is 3IAM glue input files, will be crawled. So these are the different tables or files or folders rather. Now I'll add the S3 data source. So it has been added. Then there is one more option called custom classifier, and this is used to create a classifier for a different type of source. Don't get intimidated by the name because it is nothing but the format that we mentioned, format and all the other options along with format that we mentioned while creating a data frame reader in Spark. We have done that multiple times. It is nothing but providing the format keyword along with that various options that you can pass. So I'll skip this one, click on next. And IAM role is very important because Glue is a AWS service, so it has to connect to various different other services. For example, I have shown you S3 source. S3 can be there as a target also. Then you can have Aurora database, Redshift, Snowflake, etc. For them, we need an IAM role. So I have already created the IAM role. It is just like all the other IAM roles that I have created so far. This is the role 3am glue data catalog role which I had created long back. What will I do is that I will remove the other roles and add the administrator role, which is administrator access. So I'll add the permission. That's it. I have administrator access, Glue console full access, and AWS Glue service roles. These three are needed. And I have another permission of pass role, which is also important. And this is how it looks like. In the effect, I mentioned allow. In the action, I mentioned IAM colon pass role. And in the resource, I mentioned the role itself, which is this role. Okay, so that's all. This is the IAM role that I have created. Now, I'll attach this IAM role here. And we do not need any lake formation configuration, and we do not need any security configuration also. So click on next, and I'll have to select a database where the table definitions would be stored. As you might know that it would be stored as a table definition because it is similar to Spark data frame reader, right? So whenever I use the print schema API, it shows us the structured schema of the object that we are reading. So that's why I'll have to mention the database in this case. And if you want, we can provide a table name prefix also. Let's say I mention 3im underscore. Now all the table names would be created with the prefix 3im underscore. And then we have the scroller schedule. I can mention it on demand, hourly, daily, weekly, monthly, etc. Typically in production environment, what happens is, let's say you know that your schema might change over 1 week or 1 month or maybe in a quarter. You can mention that weekly, monthly, or we can mention custom also using a cron expression. And if you know that your schema will not change, so the schema would remain the same, then you can run it only once and forget about it. Of course, that is not the case. In most of the cases, when you use relational or non-relational databases, the schema changes or the structure changes. Depending on how frequent are your structure changes or schema changes, you can schedule the crawler run as per that. I'm selecting on demand because I'll be running it only once. Now that's what. Click on create crawler and it has been created. After the creation is done, we see all the options here, the name, IAM role, etc. Tells you the state also, the table prefix. Then you have schedule. Here I mentioned the frequency as on demand and the data sources is only S3. It will also show you the exact location of the S3 folder. Then you have classifier. We are using a plain and simple basic classifier. In most of the cases, this should suffice. Then you have tags. Then we have crawler runs. I have not run the crawler at all. And then we have various advanced settings like create single schema for each S3 path, object deletion in data store, etc. Now let me go ahead and run the crawler and let's see whether the execution is successful or not. So I've just clicked on run crawler here, or you can run it from here. And then the moment you refresh, it will show you that it is running. The status is running now. Now we'll wait to see whether the crawler run is successful or a failure. So if it's a failure, obviously we'll have to debug that. You can imagine that it is running a Spark job, actually multiple Spark jobs with the infer schema, and it has been completed. It tells you what are the various table changes. So it says there are 5 table changes and 0 partition changes because we did not have any partitions. The execution took 39 seconds to complete. Now let's go to the data catalog. The crawler run is done. So now we should be able to see 5 tables. You have to refresh And now it is showing you all the tables. You have account table, customer table, ledger, loan, and transaction table. And all the table names have been prefixed with 3im underscore. Because while creating the crawler, I mentioned that the table name prefix should be 3im underscore. So it has added that. This is the database and this is the location of these tables. Now, these are all S3 locations you see. So 3im account table is pointing to this location. And the classifier is CSV, which is nothing but the format. All of them are of CSV format. You can use Parquet also. Then there's view data, data quality. I'll talk about data quality later on, and then column statistics. Right now, there are no statistics as such. Now let's go inside of this table, which is 3im account. And this is what the schema is. We have account ID as big integer, customer ID as big integer, balance as double, currency code as string, and account opening date as string. This is the schema of the account table. You can edit it also. We can click on edit schema and change it. Let's say I can select this, and let's say I want to change the data type. I can click edit here and then mention the data type to be as date or timestamp, whatever. I'll not do it right now. And I can edit the schema using JSON also. So this is what it shows. This is the name of the column and this is the type of the column. So you see, this is nothing but an output of print schema API that we have seen in Spark earlier. What Glue crawler has done, it executed the Spark data frame reader, or created a Spark data frame reader rather, understood the schema and printed the output. Now, instead of printing it, it has stored it in the database that we have provided. Now, this is completely serverless. We did not have to mention anything. We just created the database and then run the Glue crawler, and that's it. Then you have 3im customer. Similar, we have the entire schema of customer. All of it is string, it seems. Then ledger, these are the columns of ledger, and so on. So this is how Glue crawler works. The purpose of Glue crawler is to understand the schema and then store it in the Glue data catalog database. I could have used it for other sources also, like PostgreSQL database, MySQL database, or Redshift data warehouse, or Parquet files, or Iceberg files also. If I want, I can create an Iceberg table also. So if I click on add table, let's say I mention some name here. I do not have any file for that, but I just wanted to show you what things are there. This is the database, and here it tells you what is the table format, whether it is a standard AWS Glue table or Apache Iceberg table. So we can select, or we can add a table with Apache Iceberg format also, which is a Lakehouse format. And we have already seen what Iceberg is. Now there are table optimization which can be done automatically by Glue, meaning that it can automatically perform compaction, it can automatically expire older snapshots, and it can automatically delete the orphan files. These three can be done by Glue automatically. Then there are various optimization strategies. We can use the default settings, or we can mention some custom settings also. Now here in the custom settings, it tells you the compaction strategy, delete file threshold, snapshot retention period, etc. Then I have to provide an IAM role. Obviously that is mandatory. And then we can mention the path, or the table path, which is nothing but an S3 path where your Iceberg table is. We can create the crawler or add the table and store the schema here also. We can create a standard table also, and the source can be S3, Kinesis, or Kafka. Why you have Kafka and Kinesis? Because we can store the schema for streaming data also in AWS Glue, and with various different data formats. So you might have understood that one of the major purposes of data catalog is to store the metadata of all the objects that are there in your organization. Is there any other purpose? The answer is yes, there are other purposes also. The purpose is to use these different tables in the ETL job. So when we run ETL job using Glue, we can use these sources that are there in the Glue catalog. Not only that, we can use Athena to query these S3 tables also. Athena uses Glue data catalog behind the scenes. So not only it stores the metadata, these structure can be provided as input to Glue ETL and Athena also.